much time and effort is spent on extracting oil and gas from the earth, but not quite so much time spent considering the spaces this process leaves behind. However, Rosalind Archer from the University of Auckland has some very eco-friendly ideas about how these might be used. Hi Rosalind, thanks for talking to us today.
You're welcome.
Now, I just thought we'd kick off by talking about what your initial training was actually designed to do before we talk about how you might have inverted that.
Certainly. Well, I started out doing a Bachelor of Engineering Science degree here at the University of Auckland, and then I ended up doing a PhD in Petroleum Engineering at Stanford University in California. So that was very much about learning how to get oil and gas out of the ground, and I still do my fair share of that. But yeah, as you say, I've also developed an interest in putting CO2 underground.
So how does that work? How did that change occur? Because CO2 is used to help get gas and oil out of the ground, but you've got a whole different spin on how that might be able to be used, don't you?
That's right. One of the ways that the technology from the oil industry can really help in terms of environmental issues is injecting CO2 into a range of different pore spaces underground with a view to keeping it there.
Oh, okay. So how is it used initially, though, the CO2 in the gas and oil industry?
So there's a sort of a 20-year heritage in the oil industry of using it to inject it into oil reservoirs, and when you inject CO2 into oil it becomes less viscous, less dense, easy to move, because one thing that a lot of people might not realise is oil and gas are found inside of rocks. I can grab a rock actually.
Mm-hmm.
So the oil that went into the petrol in your car was probably found in a rock like this, and if you look at it at this scale, it looks perfectly solid. But if I looked at this under a microscope, this rock is probably about 22% void space. So there's lots of tiny little spaces in here between essentially what was sand grains, and it's those tiny spaces that the oil occupies. So if you inject CO2 into the oil, you can make it move more easily through those spaces.
So most of us think that, oil and gas is in some big pool under the ground.
And
but
you
in
just put a
fact,
straw into it.
Exactly. But actually you're saying it's all infused all through the rock.
Yes, it's infused through the rock. So this rock is clean. This looks just like beach sand that's been cooked under high pressure and temperature for millions of years. But if this had oil in it, it would be black.
Right. So getting that out is obviously quite difficult.
Yes.
And CO2 being pumped into that helps it move,
That's
is what
right.
you're saying.
Yeah, it changes the properties of the oil, boosts up the pressure, so adding pressure to the system helps fluids flow.
Right. And when you've extracted that out then, we have spaces left behind.
We do. So depleted oil and gas reservoirs are in a sense a resource because they're geological formations that we know a lot about. We've spent a lot of time and money understanding their geology, so they may become very safe, well understood containers, if you like, to store carbon dioxide.
So would it be a similar process that they use in terms of getting the oil out to actually put, because what you're talking about is actually putting CO2, which is a greenhouse gas, back into
Correct.
these spaces that have been left behind?
Yeah, it's a relatively similar process. One of the key differences though is CO2 is very corrosive. So if you have CO2 in pipelines, it forms acids that eat through metal. So all the metal inside the well bores has to be very carefully selected. All the cement that they use to hold the well bores in place also has to be really carefully done.
And how do you, and so if you got this back into the ground, how long would it stay there? Would it seep out again, or is it, as you said before, is it a band-aid, or is it something that would actually really help with greenhouse gases in the long term?
Well, in terms of where it goes into a few places that if you wait long enough, and long enough might be 1,000 years, 5,000 years, the CO2 and any water that's inside the rock will eventually form new rocks. It will form carbonate rocks, much like the rocks in Waitomo. Mm-hmm. So they have essentially carbon dioxide in solid form in some of those minerals. You will get CO2 dissolving into oil, dissolving into water, dissolving into gas, and being trapped in that form. And the question of whether it will come out again is a question at sort of the front of everybody's minds. Public confidence is a really key issue. So the formations that are being targeted to do this kind of thing are formations where you have hundreds of metres of very impermeable rock like a shale. Or a shale is essentially like a slate tile in your bathroom. And that rock is impermeable, that the gas cannot diffuse through it. One sort of nightmare scenario would be if you have a major earthquake that upsets everything and does create a leakage pathway. So the mechanics of whether you could cause an earthquake is something that people consider pretty closely.
So what prompted you to look at it this way? Because I mean, essentially, as you say, you were looking at ways of helping getting oil and gas out, and now you're saying, well, how about we use those spaces to put CO2 into?
Yeah, well, I think it's just a different application of the same sort of mathematics and computing skills in a space where I can really do something that I think makes a difference. So I consult to the New Zealand government and to the Australian government on this.
Well done. What sort of maths does this involve?
What sort of maths? It involves calculus. So it involves, for high school students that know a little bit about differentiation, I write equations that are full of derivatives. And even though I'm sort of good at maths, I write down equations I can't solve. So I teach my computer to solve them. My computer's much better at solving these differential equations if I write them in the right format. So I might have my computer solving literally a million equations before breakfast some days, because it's very good at doing the brute force kind of work that's required to solve the equations in a way that humans can't.
So calculus could help save the world.
It's a nice concept, isn't it? I hope so.
Do you think there's much likelihood, or has this actually been used to get rid of CO2?
Yes, there's been a major project in Norway running for just over 10 years. There's 3 or 4 other big ones in the world, and I consult to the Western Australian government on what will be by far the biggest in the world. That will be disposing of up to, I think, 11 million tonnes of CO2 a year.
Wow. And when's that looking likely to start going ahead?
Well, the first thing that had to happen was Australia had to change the laws to make it possible, because this is a real frontier area, so there was no legal framework to do this. So the state and federal law changes have gone through to give the company the green light to say they could do it, and they're finalising their designs at the moment.
Wow. And you're consulting with them?
Yeah, I'm a consultant to the government side of the equation to essentially look over the company's shoulder and try and assure the government that everything's above board and they've done the calculations right.
And you enjoy doing this, obviously, because
yes,
I mean, it's not just the mathematics that obviously you like. It's also got a sort of a social application that you wouldn't have really thought of.
Yeah, no, it's important to me to work on problems that are real, that have impact. So this area is a way I can really use the maths to do something interesting.
And it is ironic somewhat that it's come off the back of an oil and gas type engineering area and suddenly turned into a greeny one.
It is, but ironically it's people in the oil and gas industry that have these skills.
That have the information and the expertise.
Yes.
Yeah.
But I use the independence that I have, that I work for a university, not a company, so I can apply those skills in whatever area interests me.
Well, that's really fascinating, and thank you very much for talking to us today, Rosalind.
Sure, you're welcome.